So in this video, we are going to apply factor theorem to find remainders. So it is the first level of remainder theorem assignment on Delta Math. Okay, so we're going to be working with level 1 of the remainder theorem examples assignment. So the first problems, this example problem says you are given a function, you are given a factor. So we're going to, what to divide by, not a factor, but another binomial to divide by. So we're not sure if it's a factor, so we're going to test it. So we're going to first do the fast way to do it is to apply factor theorem. So that means that if we do f of 2, the answer that we get will be the remainder. If it is 0, then x minus 2 is a factor. If it's not 0, that means there's going to be a remainder, all right? So let's try to plug in. We're just going to plug in 2. So it will be 5 times 2 to the power of 5. All right, we're plugging in 2 for x plus 4. This is a fast way to do it. So we'll do 5 times 32 plus 4. And 32 times 5 is 160. Let's see, 32 times 5 is 160. So this will be 164. Done. This is the remainder. Because we plug in that, it's a remainder. It doesn't have to be 0 all the time. If it's 0, then it's a factor, but it's not a factor. X minus 2 is not a factor of this polynomial, so we have a remainder, okay? Now, that's the fast way, and I recommend this way. You can do the long way. This is the long ways to do synthetic division. So put 2 over here, and then you do 5, 0, 0, 0, 0, and then 4. If you are wondering why I put 0, this is because this polynomial has missing terms. So it will be 5x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x to the 2nd plus 0x. Let's erase that thing. And then finally plus 1 plus 4. So that's where I have 1, 2, 3, 4 zeros. So be careful with that so you don't get tricked. So now we're going to bring down the 5. 5 times 2 is 10. Add them together, that's 10. Times 2 is 20. Add them together is 20. Times 2 is 40. Add them together is 40. Times 2 is 80. Add them together is 80. 80 times 2 is 160. And then add them together will be 40. This is 80. Sorry, this is 80. I was jumping ahead of myself. 2 times 80 is 160, and then you add them together, you get 164. Okay, we got the same answer. Easy. This is the easy way. All right, the efficient way, fast way is just by plugging in. And then this is the longer way. You can choose whichever way you want to do this problem. Okay, that's level 1. Here is a problem from level 2. All right, level 2. It's a little bit more steps to do, so it's level 2 right here. All right, so in this level, you are told that a particular binomial is a factor. It's a factor. We're going to use the fact that this is a factor. So that means that when we do whatever we plug in f of -1, we must get 0 because x plus 1 is a factor. So we're going to see what's going to happen now. So that will help us to find this k because we're going to set it to 0. All right, let's plug in -1. So f of -1 is 2 times -1 cubed plus 7 times -1, and then plus k. All right. Because it says it's a factor, we have to say equals to 0. We have to set whatever answer we got here to 0, okay? So let's plug in the rest now. So -1 cubed is -1 times 2 is -2. -1 times 7 is -7. Plus k must be 0 because that's a factor. And so we have -2, -7 is -9 plus k equals 0. All right, so then we can actually, let's remove this. So we can actually now solve for k by adding 9 to both sides. Add 9 to both sides. So k must be 9. Okay, that's the basic idea of using the fact that one of the what's given to you is a factor to find a missing, to find something that is a variable that is standing in the place of one of the terms. Okay, so here we have it, k equals 9, and that's what you're going to type into your into the box. You can actually confirm this if you want to by setting k equals 9 and dividing. You will get 0 at the end. Okay, all right, that's I think those are the two examples I have for remainder theorem. All right, I hope this helps you a little bit. Remember to get I on math, not on math.